Sustained neurotransmission requires a constant supply of synaptic vesicles and recycling of synaptic vesicle membranes at the presynaptic terminal. This animation illustrates a mechanism for synaptic vesicle recycling called ultrafast endocytosis. Axons form swellings termed boutons where they contact dendrites to form synapses. Synaptic vesicles filled with neurotransmitter are clustered in the bouton, and some are located near the active zone, which is the site of neurotransmitter release. Some synaptic vesicles are in contact with the plasma membrane and ready to fuse. These vesicles are referred to as docked and primed, and they constitute a part of the readily releasable pool. Unlike Clathrin-mediated endocytosis, endocytic proteins such as syntepin-1, dynamin-1-XA, endophyllin A, and synaptogenin-1 are phase-separated and pre-accumulated at the plasma membrane on the lateral edge of the active zone or periactive zone, marking where ultrafast endocytosis takes place. This pre-accumulation is organized by syntepin-1 and dynamin-1-XA and is necessary to accelerate the endocytic reaction. Upon arrival of an action potential or an electric impulse, primed synaptic vesicles fuse and release neurotransmitter into the synaptic cleft. Fusion is mediated by the SNARE complex and the calcium-sensing protein synaptotagmin. The core components of the SNARE complex are synaptobrevin, syntaxin, and SNAP25. Synaptotagmins trigger exocytosis in response to local calcium entry through voltage-gated calcium channels. Within 50 milliseconds of exocytosis, the newly added membrane causes buckling or invagination at the periactive zone. Syntepin-1 deforms the plasma membrane, inducing curvature, and oligomerizes, leading to pit formation. Synaptogenin-1 preferentially hydrolyzes PIP2, causing negative curvature. Endophyllin A oligomerizes quickly, stabilizing the neck of the endocytic pit. Pre-accumulated GDPase dynamin-1-XA forms a helical oligomer, immediately pinching off at the neck of the endocytic vesicle within 100 milliseconds. The endocytic vesicle rapidly traffics away from the plasma membrane towards an endosome and then fuses with the endosome. New synaptic vesicles are regenerated by budding from the endosomal membrane. Vesicles are cleaved by dynamin. The Clathrin coat is removed and V80-pase pumps protons into the newly formed synaptic vesicles, creating an electrochemical gradient across the membrane. Transporters utilize this electrochemical gradient to load the synaptic vesicles with more than 1,000 neurotransmitter molecules. Refilled vesicles move to the active zone to maintain neurotransmitter release.